Thank you very much. Very kind. Glad you made it for the last slot during that awesome conference. Yeah, thank you for having me, actually. I will talk about Gradle 3.0 and beyond, so features we lately added, or let's say some of my, let's say personal highlights of the latest features we added to Gradle, and what we're currently working on and what's coming in the upcoming releases. 3 sentences about me. My name is Rene Groeschke. Actually, I live in Berlin. I'm principal engineer at Gradle Inc., the company behind the Gradle open source build tool. Working there now for almost 5 years, doing consulting, core development. Yeah, and I have, surprise, a Twitter account and a GitHub account. I'm talking about Gradle 3.0, so who of you does not know what Gradle is or how Gradle looks like? Perfect, I can actually skip my first slides. So, you know most of that already. So, simple Java project, Gradle is task-based, has some plugins, a groovy DSL by default. We talk about later about changes to the DSL format. Yeah, that's actually it. So, maybe one surprise as a talk is about Gradle 3.0. We don't do any big bang releases in Gradle, so actually 3.0 does not have many or more features than, let's say, 2.14 had, or new features, or as Gradle 3.1 had, we just released in September. I was asked during the speakers dinner actually why 3.0 does not have so many features and it's called 3.0. So the reason for that is that we have a really kind of tight release cycle. We release every 4 to 6 weeks a new version. And the major difference to the difference to major releases compared to minor releases is more or less just about dropping support for deprecated features. So I remember when we worked on 2.0, our CEO Adam or CTO Adam was asked, what will 2.0 bring to Gradle or to the Gradle community? And what he said was it will actually piss people off because all the deprecations has been removed. So in general, you should be fine with updating to newer versions because we are really strict about not breaking any functionality apart from doing this on purpose when we do major releases to move on and refresh the code base, so to say. So I picked some features that have been there, as we have no big bang releases, that has been there before Gradle 3.0 and some that came after 3.0 already. So let's start with a simple one. The typical workflow of a developer these days is more or less edit your code base, run the build, examine outputs, and then again edit the code base, run the build, check the tests, and again edit, run. So we are an automation company, and Gradle is an automation tool. So what can we do to make that easier for a developer? What we did, or what we want to have is to shorten the cycle, the feedback loop for developers. Therefore, we introduced this tiny little but really convenient feature of continuous builds. So what it does is it triggers a task inputs and outputs and rebuilds if anything has changed. And that offers the developers a really fast feedback loop. So maybe let's take this as an example. I made that typo on purpose. So what we can do here, where do I have my slides? So I did my slides with Gradle 2, so I can do, I use that awesome ASCII doctor tool for creating the slide deck. So we run the Gradle build, create that ASCII doctor stuff, and now we see Gradle has not stopped, so it's waiting for changes on input files of tasks. So if I go here now, I see here's a build stuff, so I want to fix that. What can I do? I just need to go to my sources of my slide deck. I hit save, and what I see immediately here is that Gradle kind of auto-detects, oh, actually I can use that fancy pointer here. You can see that it auto-detects the changed file, and it triggers a rebuild, and the build is successful, and now I can go to my slide deck, hit refresh, and got that. Especially people, anybody using Play, the Play framework, or JavaScript? Anybody doing JavaScript? We introduced that feature we added Play support out of the box. The Play framework does that automatically, so you have, you don't need to restart your application or anything. You have immediately feedback in your browser actually for the app. Yeah, nice little feature, really convenient. I use it all the day when, for example, when we do documentation fixes, we do our documentation in markdown, and that's really kind of convenient. So, next topic. So who of you is doing TDD or claims to do TDD? Okay. Who does not but still thinks he writes decent tests for their code? Yeah, okay. That's more or less what I tend to say about how I code. These days, I think you have 3 crucial parts in your code base usually that forms the product. Actually, obviously, the production code, more or less, and for that you usually write test code. Then you have your test code. That's the second big thing you have and need to maintain. But the more ambitious your automation gets, the more complex your build logic gets. I don't know what you're working for. If you're just building a small library, I guess it's not that tricky. But if you do big releases, big software stack with lots of components and stuff, and automate more and more in your build infrastructure, automation can get quite complex. So what people asked or really looked for was a way to test build logic. We had some of that stuff internally available for a long time, and what happens actually is that the Netflix guys more or less forked our internal ways, or it's still open source, but it was internal, it was no public API. They forked our test infrastructure code and made a public plugin out of that. There are plenty of plugins written by the Netflix guys called Nebula whatsoever, and there was a Nebula test plugin. And then at one point, they were kind of tired of maintaining it, so they asked us to make it public. So actually, they sponsored what we call Testkit. So Testkit is a way to write functional tests for your build code. There are already some test fixtures in there if you want to write unit test code or unit test for your task, your custom task or your custom plugins. But if you really want to have functional tests, like really running an actual build in your test, that's what you can do with Testkit. It's actually pretty simple to do. There's a shortcut. So what we do here is we have a simple build.gradle file, Maven Central. I like to write my test code in Groovy using Spock. I don't know if you attended Andres' talk, so he gave quite an overview of Spock. And what I do here, what's now specific is that I call this shortcut Gradle Testkit. What this will do is it will create an API or put an API on class path that lets you write test code. And that's an example of a hello world. Actually, let's do that in the IDE. So here I have I don't know, anybody using Spock? Anybody has seen Spock before? It's kind of a groovy DSL on top of JUnit, but you can do all of that stuff you can use with plain JUnit. So often people get confused that they say, okay, I don't know Groovy that much, so they kind of hesitated to write more build logic or custom plugins or custom tasks. But actually what you can do in Gradle is you can implement all that stuff in plain Java if you like. So if that stops you from using Gradle, don't hesitate. So that's how my functional test looks like. So let's, maybe if we go to the build.gradle file, it's more or less exactly what I had before. So I had this Gradle Testkit here. I imported that in my favorite IDE. And now if I run that test, what we do is, so the API is quite simple there. There's a Gradle runner you can create. It uses a builder pattern. And what you can see here is that I pass in the project directory, add some arguments. So this test is really simple. I was told this is close to Hello World. Is that true? Okay, fine. So I have no clue. sorry. What I can do, or maybe if you're more ambitious about your plugin development, or maybe you're thinking about providing open source plugin, you want to ensure that your plugin works with different versions of Gradle, right? So even though we claim or we try to be really careful about not breaking things happen, right? So it's better to test that. So what can you do about that? Or maybe in your company you support different teams and different teams use different Gradle versions. What can you do about it? So in Spock, it's really convenient to have parameterized tests. So what I do here is that unroll functionality comes with Spock. And I change the name of the test to say hello world task, prints hello world, with Gradle version. So here I reference a parameter, but now I need to declare that parameter. So in Spock, that's really convenient. All you need to do is declare where clause, and then you can say version, and then you pass in different version. Let's pass in different Gradle versions we want to test. And the only thing that's left is you need to tell the test or the Gradle runner which version to use. And now if we run that again, actually I'm not sure where that no name is coming from, but now we have a parameterized test with coverage for Gradle 3.0, 3.1, and as I'm pretty sure with this simple snippet, it should work with Gradle 2.14 also. Yeah, okay. So really easy to write your test code. There are more functionality documented if you want to test certain plugins and so on to make that more convenient. But I really encourage you to test your build logic if it gets more complex. And it should be getting more complex because you want to automate more stuff. Question. Who thinks that their build is too fast? Anybody? With Gradle you got close, right? But actually, I never met anybody who said the build is too fast. I once was at a client for 3 days, and they had a build which took 1.5 minutes, and they let me came in to make that fast, and I said, "What the fuck? What are you talking about? It's really fast already." So builds usually never are too fast. So my colleague Cedric Champeau, one of the committers of Groovy, he wrote a big article or good article on our blog about considering performance as a feature, because making things faster is not just about, okay, not just a build gets executed faster, but it lets you kind of work differently. If the feedback loop is smaller or shorter, you just work differently, in a different way or interact with the tool in a different way, I think. So what we did in the last couple of months, or we started in March or something, we had a dedicated team at Gradle who invested in making the performance of Gradle better, and they are still going on, still doing some stuff there. So what we got so far out of that dedicated performance burst is massive reduced configuration time. Another thing for bigger builds, usually not for a simple library, but for example, LinkedIn has builds with more than 4,000 submodules, and they have about 4,000 build scripts. There is some compilation of that build scripts going on because it's groovy. We did caching up front, but now we optimize the compilation. We improved the up-to-date checks. Later on, I talk a bit more in detail about that stuff. Another thing that especially made us mad, kind of, was that originally the pure execution of test was slower than in Maven for a fraction of a little bit of time, and yeah, that was kind of something we definitely wanted to solve as part of that. We are investing a lot in IDE support these days, so we have a dedicated guy working on BuildShip, the Eclipse plugin for Gradle. I always mix that up. It's not the Eclipse plugin for Gradle. It's not a Gradle plugin for Eclipse. It's an Eclipse plugin for Gradle. You know what I mean. So we spend a lot of time in making that IDE integration faster. And what turned out to be kind of a bottleneck in different builds is dependency resolution. And that got, especially in Gradle 3.1, you will notice a huge difference compared to 3.0. It's an ongoing effort. We have still like, I don't know, 3 or 4 people working on that. Anybody using Android, doing Android development? Yeah. We currently focus on improving the performance for Android too. So what we do when we develop things and when we talk about performance and so on, actually we kind of data driven. So all the work we do is we measure during nightly builds. We have performance builds. So that's actually a snapshot from our CI. It's been a while, so that was in April already. So you can see there's a huge drop in the configuration time speed up. And that's what I mentioned earlier, that Gradle was a bit slower in test execution with Maven. And yeah, we tried really hard, and now we're tremendously faster than Maven. So if that's the reason you need to switch, yeah. If you have a JVM, yesterday there was a talk, I don't remember, somebody said, of course it's starting slow, it's Java. We hit that very early, especially when we wanted to have IDE support with invoking Gradle from the IDE. We wanted to have fast feedback. So what we did then is we started working on what we call Gradle daemons. So it's a background process, long-living background process that avoids the costs of a JVM bootstrapping. And also, so every build or multiple builds in a row got executed by the same JVM. That provides us, so you save the costly JVM bootstrapping. And the other thing is we noticed that also the hotspot compilation is much more efficient. Like, yeah, it depends, of course, on the build. But like the 6th build or something in a JVM is usually much faster than the 2nd. So that's based on warmed up hotspot compilation. We have more ideas to leverage that daemon. So it's on by default since 3.0 now. We deal way better with memory leaks these days. So since Gradle is, allows you to add custom plugins and write your own plugins, and we have to be kind of conservative when we deal with memory leaks. Not saying that you as a Gradle users are the only guys who add memory leaks. Our plugins may have memory leaks too. So we need to have a good conservative way to deal with that. We added some clever exploration strategies to make the daemon more smarter when to restart itself or want to fork another one. We make it a bit more communicative. You will see in my next demos. And we have plans to leverage the daemon even more in the future. Like we can hold data about up-to-date status in the daemon, what we already do, and we can hold way more stuff in the daemon. Or we can have a listener on the file system that detects if a file has changed and immediately do the task up-to-date check, calculating the checksums, all that kind of stuff. If you're using Gradle before 3.0, you need to enable the daemon on your own. Easiest way is to set all Gradle daemon to true in your Gradle properties. Yeah. This is the first conference where I expect people to know what that is. Yes. So I did a similar talk at other conferences in Berlin or in Germany. Nobody knows it, but this is actually, I was told this is Kotlin. So why do I want to talk about Kotlin? It's not just because I'm in St. Petersburg, it's because one thing we noticed over the last couple of years, or I have to admit, we also kind of underestimated, is the demand for having not just good IDE support in terms of executing builds, but also in editing build scripts and so on. And with Groovy, it's kind of, let's say, tricky. For IntelliJ, it's awesome Groovy support, so you have some code completion there, but as you can imagine, the code completion for dynamic DSL is way more complex than let's say for XML files other build tools use. So, and on the other hand, for Eclipse, for example, I think at the moment there's no active development going on for Groovy plugins. Correct me if I'm wrong, but that's what I know, or that's what I think. So what could we do to add better IDE support? So what we actually want is we want to have support for refactoring, code, lookup, code, drive, navigate through the API and stuff like this. So that's when Kotlin comes into play. Kotlin, I guess, who doesn't know Kotlin? Doesn't or does? Kotlin is a statically typed language written by the guys from JetBrains. So it's open source, but written by the JetBrains guys. And I guess most of you know JetBrains is just awesome in IDE support. So Kotlin is really, what I like about Kotlin is it's driven by pragmatism. It has deep support in IDEA and Eclipse, because if you want to have a language that is taken seriously, you have to support both, I guess. I don't know the status about NetBeans. Any NetBeans people here? Okay. But it's really driven by pragmatism. It looks a bit like, I think it looks a bit like a mix of Groovy and Scala. And it allows a declarative syntax for creating DSL with ease. There has been some Kotlin talk, so I'm not going into detail how Kotlin looks like itself. So in Gradle, we added support for Kotlin support in 3.0. Again, it's an incremental thing, so it's nothing we do in a big bang release. With Gradle 3.0, I expect that to come out in, I think next week is a release candidate, and then maybe in 2 weeks, there will be even better support for multi-project builds and so on. And just to give you an idea how it looks like, that's a simple DSL, a Gradle DSL written in Kotlin. And some of it looks really similar to what we had in Groovy already. We're working closely with the JetBrains guys here, so it's getting better and better and better. And the latest version, again, will be in 3.2. So if you want to create a task, you can do all that stuff. And there are really, I think Spring is using that already in some of their builds. And some other open source projects I know have ported their builds to Kotlin. Especially in so who of the Android guys does Kotlin for Android? Sorry?
There is no ability in Thirdparty to write Android builds with Kotlin.
No, but I mean, and use Kotlin for Android apps, let's say, not just builds. So I was told it's getting way more popular, but okay. Yeah, that's about Kotlin. We're really excited about that. The Groovy community got kind of, afraid that we don't support Groovy anymore. So Groovy will stay there and we will support both, but we needed an option for moving on with first-class IDE support, and Groovy didn't offer anything that there yet, and we don't have the bandwidth to do that on our own, so that's why we moved to Kotlin. It's a good relationship with JetBrains. Have you ever wished to combine two builds? Have you ever wanted to make a tiny little change in a third-party library, and it was a kind of a hassle, just to see if a patch works, or if it's a third-party app or third-party library that does not work, or is it you, or who of you is doing something like microservices? So popular. Usually everybody's talking about microservices, but nobody does. So we added something called Composite builds, so that you can combine easily two complete separate builds into one. Stefan Faber, the guy who wrote Mockito, was really happy about that. So I learned that you quote famous people instead of telling yourself how great that things are to get the message. So with Gradle 3.1, I think it's really easy to include third-party dependencies as a from source. So you have two options to do that. One is to use a settings file to include a build programmatically. So you can have a dedicated settings file where you point to different repositories you have cloned into your machine, or you can do it ad hoc from the command line by just passing -- include build my utils and then trigger a command. Let's see an example of this. Maybe what I did here, somewhere here, I have a really simple library created, which does nothing useful, just uses some third-party library. I use, so this is my, maybe go to the build.gradle file. So what we do is, it's a simple Java project. It has some tests, some normal dependencies, and it depends on commons lang 3, sorry. And what I do here is, in my IDE, so I imported it into IntelliJ. What it does actually, when I reference random string utils, which is coming from commons lang, is it reference a file within the Gradle cache, right? It got downloaded from Maven Central, put in the cache, added to the IDE. So here you see that file. So now if I want to change that behavior of random alphabetic just for testing, there's no way of doing this, right? Because it's just a jar. I don't have the ability to do that. What I did actually is I cloned that repository up front. So here we have the commons lang repository I cloned from GitHub. So what I could do here in theory is I can include that build in my Gradle build now. So let's start. Unfortunately, that does not work. Anybody an idea why it does not work out of the box? I need a settings.gradle file, so what does it maybe mean? I give you a tiny little hint. Actually commons lang is written, or it's built with Maven. So what can we do about that? So we can go there and we can call Gradle init, which does some automatic conversion from Maven to Gradle. So now we have a build.gradle file and we have that settings file that we missed before. So let's ensure it works on its own. So it does. So now if I go to my library and do that. So what I see here now is that, by the way, that's a chatty daemon. So it tells you more how the daemon was facilitated. And now I got this message here that I'm configuring that commons lang build. And what we see here is I'm not just building a simple project, I build commons lang up front. I compiled the jar, I compiled the resources, and then I generated the idea files. And now, hopefully, what I get, damn it. Damn it. I cheated up front and now my cheat is not working, so bad. I need to do one more fix here, I think. I need to apply the idea plugin. Let's do it again. Too bad. Again, generate this. Yeah, and what I have now is I see that commons lang is not there anymore, but commons lang is here as a project. And if I navigate from my library to random, I can now return something like foo. So it makes it really easy to combine multiple repositories, especially in bigger corporations where you have complete separated builds, different teams working on that. It makes easy integration. What you can, for example, do is you have two teams working completely separated and just build both together on the CI platform in a later time in your build stage. Really nice thing to do. Yeah. It's out of the box supported by BuildShip, our Eclipse plugin, and IntelliJ just announced that yesterday that they have composite build support in IntelliJ. So if you import a project there, you can select multiple ones and it will automatically work. Yeah. Incremental Gradle builds. The best way to make a build fast, or the best way to make something fast is to not do it at all. So that's how incremental Gradle builds work. So what they do out of the box is, if a task has not changed, we don't execute the build anymore, right? So if the inputs, for example, let's take that compile task, if the sources haven't changed, the classes are still there, and the compatibility level hasn't changed, Gradle marks the task as up to date. That functionality has been there for quite a while, I think 0. whatever. So it's been there forever, and it makes incremental builds really fast. The way it works is actually kind of restricted. So what we did so far is we consider artifacts from the last time we invoked the builds, and we invoked especially this current build, on this machine, a task is considered up to date. That worked pretty well, but still what happens is that you have a team with 200 developers. What they do is at least they build everything 200 times, right? So why not leverage this stuff? So I think we can do better, and actually we did better. Why shouldn't it not be possible to, from any time we build our project before, or rerun any build anywhere, why not reuse artifacts from there? So we call that task output cache. That's kind of actually I created that with an older version. So what you can see here is that I run Gradle clean assemble, and even though I run a clean task, some output here is cached, like compile Java is not executed even though I run clean. Actually just, and let's go to a sample instead. Task output cache. So that's kind of a really simple, let me first clean up task cache. Okay, even better. If I run Gradle clean build, pardon? You mean? Thanks. So I run the clean, the jar got produced, and if I run the clean again, everything is up to date. That's a mechanism which has been there forever. But what I can do actually is, if I run it with -d, if I enable the cache, so that's actually under development. So it's at the moment it's a system property you need to pass. So what I do now is I set a flag to activate that Gradle cache, and what I do is I run it clean. So I wipe out the build directory. The first time I do that, everything looks the same. The reason it looks the same is actually it was promoted to the cache once it needs to be built, right? So now it's from cache, and it's not from the local or from the project-specific folder anymore. So even if you imagine you have cloned the repository multiple times for different branches, release branch, master branch, you can reuse artifacts from cache and don't build anything that has been built before again and again and again. So that's a first step. So, but I mentioned that we wanted to build, you want to share artifacts maybe between different machines. So what we did for that is, or what we currently spiked is a Hazelcast baked cache. So let me run that. Oh, damn it. Oh, it's already, so it's been, I created a Hazelcast server, nothing fancy there. So Hazelcast, again, there has been some Hazelcast people out there. It's a distributed cache you can leverage in your application, and it's really easy to use. So if you need distributed cache, Hazelcast is really easy way to do that. So now, what I can do now, I needed to add a custom plugin. So I mentioned it's under development. So I still run, I do run clean run now. Nothing is cached before. But where's my Hazelcast? So let's run it with -e, I think. Oh, maybe not, maybe D. So here what you get now is, if I run that again, I can see that, damn it, I can see that the output, or the cache, sorry, the artifacts for that compile Java task are now not picked up by the file system, but they are picked up from running a Hazelcast server. So that, imagine you're running a Hazelcast server in your infrastructure. You can ensure that nobody builds exactly the same output twice, and you can save really a lot of time there. It makes builds really efficient. Maybe out of interest, so with all this functionality, we do dogfooding in our own CI infrastructure. So again, we're data driven. We test that all the time on our own and see what the outputs are. So we have a build like sanity check, which does just check style or code narc. So in here you can see it's way faster, and like, especially there are different scenarios, of course, it depends on your build, and it's still under development, so we're making things better and better and better. But for example, in a scenario where we have just changed test code, for example, the build got tremendously faster on our CIS system. So in 1 minute instead of, I don't know, instead of 17 minutes. And you can try that with 3.1. So I use 3.1. You can try that with that version yourself. And we're happy to get feedback on this. Yeah, and that just filled or adds more beef to the story when we talk about performance, right? No build is fast enough. Yeah. That about task output cache. Yeah, the demo I just showed. What we've seen, usually there are people who are really passionate about automating builds, and there are people who are not, developers. But when you get developers talking about builds and they're not passionate about it, actually they are kind of, or maybe they're passionate, but they are swearing a lot about the builds. So, and for example, I did now consulting for build automation and that kind of stuff for the last couple of years. So we use builds. So we use builds to communicate things, or we need to talk about builds in different ways, and collaborate on making builds better, and so on and so on. So wouldn't it be nice, or at one point we thought, wouldn't it be nice if we could easily share builds to debug issues together with our colleagues? So have some better way of collaborating on a Gradle build. Or for example, make it easier to optimize build performance. Wouldn't it be nice to easily understand where our build time is going and make our builds faster? Again, making builds faster is the ultimate goal for a build master, I think. Or wouldn't it be nice to compare different builds in our entire organization? So we have clients that have more than 1,000 developers, or like the LinkedIn, they have, I think, 3,000 developers, and they build, of course, in CI, but they also build on the local machine. So wouldn't it be nice to compare all the builds in an organization, not just the one on CI, and see the difference there? Or wouldn't it be nice to discover how your developers, your big team is using the build actually? What is the impact on some update of a plugin? Or maybe your developers are not using the build as you expect them to use them. They always run Gradle clean, so you need to teach them how to do builds correctly in Gradle. Skip the clean task. Or wouldn't it be nice just to see where time is wasted in your builds? There's this XKCD comic where the boss is saying, "Hey, what are you doing?" And they say, "Build is compiling." Wouldn't it be nice to get data for all the builds in your infrastructure and not just CI, also your developers' local machines? And for that, we started to work on what we call Gradle build scans. So it's a cloud service to inside your build. You can view and shared using a URL that does not change. You can optimize, debug. It gives you some further information about your build. And you can use builds as a communication tool. So what we, for example, think of or did is you can have a sample build where you see how, for example, some Apache Commons libraries that have transitive dependencies that does not work out of the box. They are there. It's easy to communicate that with such a build scan. And that offers you a way to analyze all your builds and not just the ones on CI. So you actually get the transparency of how a developer uses the builds in your CI or on his developer box. Do I have a sample for that? Sure. So what we can do, or the easiest way to create such a build scan is, it's actually just another Gradle plugin you need to add. So what I did, is that readable? Yeah, it is, I think. Yeah. So all I did here is I applied the plugin, build.com Gradle build scan version 1.2. Created a license, added a tag. And so you can tag build scans with some random values. Let's, for example, that's a Gradle build itself. So what I do here is I test the jar-coco module of our build, just as an example. Shouldn't take too long. So and what you get out of that is, or at the end of the build, you get your information gets published. And now I need to figure out in which browser. Yeah, that's the one I just created, I think. So what I did here, so this is how a build script looks like. This has my face on it, not your one will have different faces, hopefully. You can inspect all the tests that was executed here. You can dive down there, get the details about each test execution. You can inspect all the dependencies you have. Like if I want to look up is SLF4J used, I can check that. It provides you some information about your build performance. So if I go there, there's a total time, how much does startup took, how long does configuration of your project took, and it gives you also some statistics about the daemon. That's what I mentioned earlier about making the daemon more communicative, so not just on the command line, but also in the Gradle build scans. And it provides you with certain suggestions what you can do to make your build even faster. So, okay, I use a development version here, but I, for example, haven't executed Gradle in parallel, what should offer more performance improvements. And with our latest release of that Gradle build scan plugin, you can tag the builds, what I mentioned earlier. So you can have, I marked that as here at Joker 2016, and actually I marked that scan to the overview of the build I created, and here's a title. And since it's all groovy, so if we go back here, so all you need to do is you get an extension build scan, and then you can create those tags using methods. You can create a value, custom value, name value pair, and you can provide links. And this is all groovy code, right? So it should be easy to extend that to add some more dynamic to it. We have plenty of ideas to do that, and we do that in our own custom builds. But so I can show you, maybe just to give you a broad idea, we use it a lot to, for example, link to our SimCity build, get information about the commit ID. Maybe that looks kind of overwhelming what we do here because it's code, and you might want to have that in a nicer way. But actually what my friend Cedric just released a couple of days ago was exactly that. So if I go to our plugin repository and I look for scan, there's a build scan plugin you can apply, and then there's build scan receipts, which is actually a beta version, but it works nice. I usually say make things final early. So what I can do is can just apply this plugin written by Cedric, go to my build.gradle file, add this one, and what he did, he created some what he calls receipts you can apply. So let's, for example, so he extends that plugin as you can do with all plugins out there. And for example, let's just use that git status receipt, run that test again, or that build again. And now you, for example, get information about your git status. So it tells you, okay, the build scan was created on a dirty workspace, and the changed file was a build.gradle file. There are plenty of receipts out there. We're currently working on, for example, adding receipts for check style warnings and stuff like this. So it's more about your creativity to use it. Then as an implementation itself is really simple. Plenty of projects use that already, open source projects. So Mockito, JUnit 5, Hibernate, all long-term Gradle friends, I would say. So that's actually all the functionality I've shown is actually there in Gradle 3.1 already, so you can use that. What's next, or what are we working on? So we have plans, or we have basically already an implementation to support Jigsaw in a way that makes a migration easy. So I don't have time to cover it in detail, but there's a talk by Cedric online and on our YouTube channel, I think, where it explains how the migration path of using Gradle to migrate to Jigsaw without even needing Jigsaw. So you can do things like declare your API and your impl, and we build, or the build now then respects that. So you can't compile against a private API or something like this. The distributed cache, so what I showed earlier is kind of a draft. We want to make that first-class citizen. It's there, you can use it, but we want to make that more convenient to use and not just having a bunch of system properties there. I mentioned earlier we still continue working on that performance work. I guess it will be there for quite a while. There's ongoing work with BuildShip. So who's using Eclipse and who's using Eclipse? Who's using IntelliJ? Ah, interesting. Yeah, BuildShip is one tiny little step ahead. They just released the version 1.021, which offers WTP support. So in your IDE, you can trigger or do web development. It's all baked by Gradle, and it's not baked by the IDE again. But yeah, IntelliJ is picking that up later. The only reason BuildShip came in first, I guess, is that we do the BuildShip development and JetBrains is doing the IntelliJ Gradle support on their own. Yeah. I have to say that if you're looking for a demanding job, we hire people, and you can actually, we don't have offices, or we have offices, but all our engineers can work from home. So if you're interested to stay in beautiful St. Petersburg but want to work for Gradle, that's definitely possible. You can do home office. You don't have to wear pants. That's big advantage. Yeah. If there are any questions, we have plenty of minutes left, and I will be there afterwards. Yeah, shoot.
So, when it will be possible?
Excuse me. Okay. So thank you for the talk. And one question as an Android developer is very important for me, is when it will be possible to write build scripts for Android in Kotlin. So at the moment it's not possible.
I think there's some initial work there. I did a talk at the Android conference where I demoed that. I don't have a date for that, but I guess it should be there anytime soon. Yeah, I don't, sorry, I guess by the end, or let's put it this way, by the end of the year, for sure. Yeah, that's definitely something we want to tackle soon, because it's a huge driver for Gradle, of course, yeah. You're waiting for that? Okay, cool. I give that back to the developers. No? No.
Thank you. You mentioned while you were using the cache mechanism, at some point you were running the Gradle clean something.
Yeah.
And the cache was not cleaned. So can you clean the cache, basically?
At the moment, I think there's what I did by cleaning is I wiped out the build directory. So I wiped out the build specific output folder. Mm-hmm. That's why I did it clean.
Yeah, but it was still using a cache, even if you were running.
Yeah,
clean.
because the cache is a shared directory
somewhere else.
Somewhere else. So there are two examples there. Like here, it's living in this example, it's in my shared. That's the simplest implementation where it's file-based within a central local directory. Mm-hmm. And so you would need to clean out that cache in there. But
so there would be a command to support this clean. I mean, for example, for Hazelcast, if you want to clean something which is on Hazelcast, does it maybe it does not make sense?
I can imagine it would make sense. I don't know. Okay. I guess we offer something like it needs to be convenient, right? Yeah. So at the moment it's a proof of concept, so to say, which works pretty well. But it's like with Hazelcast, also in our example here, is that if I stop the cache, it's immediately lost. Mm. It's a memory thing.
Okay.
Yeah.
We'll have time for one more question.
Thanks for your talk. So regarding your release timelines, I have a question. So in the beginning of your talk, you mentioned that you have quite aggressive release plan. So you release each 6 to 8 weeks. For me, as an enterprise developer, I'm interested in some stable versions of build tool. So do you have some like long-term support versions in Gradle?
LTS versions?
Yes.
No. Actually, we don't.
Okay, so each version is stable, like rock.
Yes. Well, we are kind of conservative about this. So, there has been accidents, like there has been a 2.14.1 version, which tells you that something was maybe fishy with 2.14. But in general, we want to provide a way, or it's hard for us to maintain LTS versions. It's a lot of effort. We're not currently have the bandwidth to support that. But in general, updating to a newer version, so since we have that aggressive release cycle, it's easy to use a Gradle wrapper to do that. So it's really convenient. I don't know if, who of you is using Gradle? And who of you is using the Gradle wrapper? So anybody not using or using Gradle without the wrapper, use a wrapper. It's the easiest way to update or keep up to date with Gradle, and it's easy to maintain or going to a newer version. So far, we haven't faced any big issues with that approach. Maybe you can update your version every 8 weeks or something like this to wait to see if anybody else steps into regressions.
Okay, I'll do one more release with my.
Or you can easily move back. What we want to have in that build scans pretty soon is some kind of comparison, so that you build with, let's say, 3.2 and then with 3.3, and you get immediately feedback if something has changed. That would be a good way for you to verify your code is working with the latest release.
Okay, thanks.
Yeah.